density function and marginal density function, and already we covered a joint distribution function and the marginal density distribution function, and we took several examples on how to calculate the joint distribution and density functions, as well as the marginal density and distribution functions. The objective of today's class is to work on the conditional distribution and density functions. So when we have two random variables or a vector of random variables, two per se, x and y, then we are interested in defining what we call the conditional distribution of x given an event b. We already covered this in chapter 2, if you remember. However, now we will use this event b to be as an event on y, on the second random variable. So this will be an event on y, which is the second random variable. So in chapter 2, what we did is we defined this conditional distribution function given b, given any event b, and we were able to calculate it, which is the probability that x is less than or equal specific number x divided, condition or given b, which is equal to the probability of the intersection of x less than or equal to x and b, intersect with b, divided by the probability of b. So this is that given that b is not an impossible event. If it is impossible, you cannot condition on an impossible event. You cannot say that given b and b cannot happen. And from here, we defined the density function, the conditional density function, f x or given b, which is the derivative of what we have found. So this is already done in chapter 2 for single random variable, x. Now what we'll do is we will extend it to when we have two random variables. So when the condition b, we will extend to when b is an event on another random variable, y. This is basically what we'll do today, inshallah. Okay, so we will consider b, which is an event on y. So the first one is the point, there are two cases. First of all, the point conditioning, and then second is the interval conditioning. We'll talk about these two in details. The point conditioning states that the PDF of x, so this is the PDF of x, given y equal a specific number, given the second random variable y equals a specific number, is equal to the joint PDF of x and y divided by the PDF of y evaluated at y, at the value y. And this is written as fx x given y. So this assumes that fy of y has no zero value. So basically it can happen. It's a possible event. So you don't condition again on an impossible event. Similarly, the conditional PDF of y given x, this is, we read it as given x equal x, specific number. So here, x here, a specific value, and y here, a specific value. Then this is equal to the joint PDF of x and y divided by the marginal PDF of x. Again, this is assuming that the PDF of x at that value x doesn't equal to 0. Okay, this is called point conditioning. Why is it point? Because we are conditioning that y equals a specific number. We are conditioning about that x equals a specific number. Okay, Shabab? And this basically gives us the two famous equations. Fx of x given y equals the joint divided by the marginal of y. While fy of y given x equals the marginal divided by the equals the joint divided by the marginal of x. واضحة يا شباب؟ We'll give examples in a minute, but this is basically the way we do it. طبعا there is derivation which is given in this slide, but this is self-study. We will not go through it because there's basically some math here that we'll not cover. Those of you who are interested, they can go through this slide and the material in the textbook for more details of why. So now let's explain how does this work. So assuming that graphically that the joint PDF looks like this. This is a two-dimensional graph. This is x and this is y axis. And this is a PDF, fx, y, x, y. Okay, so we have a three-dimensional graph because we have x and y, 2 dimensions, and we have fx, y of x and y. Tamam? Then if I condition that x equal a specific value, so this is x equals a specific value x, then as if I am setting the value of x to be x equal x. So as if basically the function that I get is a function of y. So you can see that this red function here is a function of y. This is, first of all, it's a one-dimensional function, right? خلاص, not anymore two-dimensional, because it's only a function of y. So it changes with y, لو تلاحظوا. And it takes the shape of the joint PDF evaluated at x equal x. Okay? While if I condition at y equal a specific number, so y equal specific number y, then the resulting function is a function of x, not anymore y, because y is already set to a specific value. And it looks like a slice in the two-dimensional function that I get this green curve. And this is a function of x. It changes with x. لو تلاحظوا. And this is the way we calculate both of them. So simply the conditional PDF of x given y equals the joint PDF divided by the marginal PDF of y. So the resulting function is a function only of x. Or changes with x. طبعا if I keep y as a variable, you end up with a function of x and y. But if I specify what value is for y, then I get basically only a function of x. أي سؤال يا شباب؟ As I mentioned, this is self-study. We will not go through it. Before we go into examples about the continuous case, let's talk about the discrete case. So when we have a discrete, two discrete random values, x and y. So the PDF of x and y looks like this two-dimensional plane that has some impulses. So we have this famous example that we have taken already. The same example, we have 3 impulses at 1 and 1 with 0.2, at y equal 1 and x equal 2 with 0.3, and at y equal 3 and x equal 3 with 0.5. The same example that we have taken so far. So basically we have the discrete 2 random variables x and y are described by the joint probabilities, right? And the PDF, the joint PDF looks like double summation of deltas evaluated at x, at all the values that x take, and at all the values at y take, with the probabilities, the joint probabilities xi, yj, right? Now, if I look at the marginal probabilities, I can calculate the probabilities of px, a probability of xi for all I, probability of yj for all j. And from here, I can get the marginal PDF of y, which is summation of deltas evaluated only at different values of y and weighted with or have values or lengths of the probability of yi. تمام? Now, if I condition at a specific value of yk, then the PDF of x given yk equals series of deltas at xi. However, every delta of these will be weighted by the joint PDF, the joint probability of xi yk divided by the probability of yk. Simply, this comes from the fact that the probability that xi given yk equals the probability of xi yk divided by the probability of yk. From here, I get the PDF of xi, the PDF of x. So this gives me the PDF of x. If I have all the conditional, these are the conditional probabilities of x given y equal yk. So if I have all these probabilities, then I get basically the conditional PDF. هذه نسميها الجوينت بس عشان نراجع الشيء اللي سويناه joint probability. في xi yj is the joint probability, which is the probability that x equal xi and y equal yj. These are the marginal probabilities. هذه وهذه نتذكر. And this is called the conditional probability of x given y equal yk. أي سؤال يا شباب؟ في أحد معي ولا لا؟
يس دكتور.
طيب
يس
تمام.
دكتور.
كل شيء مو واضح؟ كل شيء
يس.
اوكي؟
يس دكتور.
طيب. So let's have an example. So here we have this another example that we have here x and y, and you have the joint PDF. So we have here x can take two values, x1 and x2, and y can take three values, y1, y2, y3, with these joint probabilities. Okay, هذه الموجودة عندك 5 over 15, 4 over 15. So here we can see that the probability مثلا أعطوني يا شباب, send me over the private chat. What is the probability of x1, y3? Over the private chat, شباب. What is this probability equal to? So this is the question. Probability of x1, y3 over the private chat. طيب ممتاز. So basically, as you can see, this is the probability of x1 and y3, which is this impulse evaluated at, which is located at x1 and y3, which is 4 over 15. Excellent. Most of you get it right. And similarly, I can find different probabilities. Probability of x2, y2 equals كم? x2 هذه هي
1
and
over
y2
15.
exactly 1 over 15. So this is it basically. It's impulse and so on. So now from the joint, طبعا the summation here, the summation of all xi, double summation, xi yj equal كم يا شباب؟ شباب
1.
1, exactly. This is the area under the curve. So this is summation over all xi and yj. This is equal to 1. If this doesn't happen, this is not a valid PDF. بس عشان for you to double check always. Now, if I want to condition on y equal y3, okay, and I'm interested in finding the PDF of x given y3. This is what I'm interested in. In order to find this, simply I need to find the joint probabilities of xi given y3. And I sum over all xi and delta x minus xi. Simply, this is it. So this is the conditional PDF of x given y3, and this is the conditional. I write it from the conditional probabilities of x given y3. Once I have the conditional probabilities of x given y3, I can write the conditional PDF. So in order to find this, simply I need to find these conditional probabilities. X can take two values, x1 and x2. So the probability that x equal x1 given y equal 3, y3, sorry, equals the joint probability of x1, y3 divided by the marginal probability that y equal y3. So in order to find the marginal, simply I need to sum هذه هي. To find the marginal, this is simply summation over all xi, probability of xi, y3 لو تتذكر. I sum over all in order to find the probability of y3 هذه. Simply I sum over all the values that x can take while y3 equal, while y equal y3. So I sum over all xi, which is x1 and x2, while keeping y equal y3. So this is equal to two probabilities. The probability that x1 y3, probability x2 y3, which is 4 over 5, 15 sorry. أول واحدة هذه والثانية 5 over 15, which is 9 over 15. Now I write this in the denominator, which is here. And I divide the joint probability x2 y3 divided by probability of y3, which is 5 over 15 divided by 9 over 15, get me 5 over 9. And the probability that x1, x equal x1 given y equal y3 is the joint probability of x1 y3 divided by the marginal probability of y3, which is 4 over 15 divided by 9 over 15, gives me 4 over 9. So the joint PDF of x has two impulses. One impulse with 4 over 9 delta of x minus x1 plus كم يا شباب؟ 5 over 9, right? Delta 9 minus x equal x minus x2. So it has two values, x1 and x2, with these probabilities. Note here that the summation over xi of xi given y3 كم يا شباب؟ When I sum over all xi and the probability of xi ايش يعطيني؟
1.
1 also. So the area under the curve of a PDF f x given y dx, this is a function of x and I sum over all x. This gives me 1. Any question about how did we get this يا شباب؟ كل شيء واضح؟
Yes, doctor.
طيب. Now let's have an example for the continuous case. So here we have the joint PDF of x and y equals this function. We have taken it before. X e to minus x multiplied by y plus 1. Ux uy. What does this mean, ux uy? Shabab, what does ux uy mean?
Greater than 0.
Yeah, it starts from x larger than or equal to 0 and y larger than or equal to 0. Now, I'm interested in finding the marginal. We have found it before. Fx of x, we have done it before. So check the slides before that. And now we are interested in the conditional PDF of y given x. Conditional PDF of y given x, as we have done it, as we have already explained, it's the joint PDF divided by the marginal PDF of x. And simply, if you divide them, you have this divided by this, you get this function. Simply, the e2 minus x cancels. And then how you divide by it. Okay? Now, I just mentioned this. تفضل. Yes, go
I say
ahead.
okay. Everything clear.
ممتاز. طيب يعطيك العافية. And I just mentioned this here. Oh, well, this is now, why is this so? If I add or I take the area under the curve of fy of y given x, dy معناها ايش؟ This is a function of y and I'm summing over all the values of y. مو x يا شباب. Okay, x here is kept constant. So this is a function of y. It's a PDF of y given x. So I sum over all the values of y. تمام? Now, just write this in terms of what we know, which is the joint PDF divided by the margin of PDF of x. Now, the marginal here has nothing to do with y, so I can take it outside. Here. I can take it outside the integral. So what do I have here? I have an integral over y of the joint PDF. And you know that if I integrate over y, the joint PDF, what do I get? I get marginal. The marginal of x, exactly. And I have already divided by fx, so the PDF of x divided by the PDF of x, I get 1. This just confirms what I have just written above. أي سؤال يا شباب؟ طيب, so basically this is what we call the point conditioning. Why do we call it point conditioning? Because we are conditioning on the event that y, for example, equals a specific number, y. Okay, or x equals a specific number, x. And we are interested in the conditional PDF of x given y. Okay. Now the marginal, نحن تكلمنا على على conditional density. Now let's talk about the distribution هنا. ما ذكرناها. The condition, this is called conditional لا مو PDF, CDF, or distribution of x given y equal y specific number. Okay, it's a conditional distribution of x given y equal y. Simply, this is the integral of the conditional density. However, from minus infinity to x, because we know that the marginal PDF, sorry, the conditional PDF of x given y will be equal also to the derivative of the conditional CDF. We know this from the relationship between any density and any distribution. So the distribution function, the conditional distribution function, is the integral from minus infinity to x of the conditional density function. However, what is the conditional density function? It's written as the joint density divided by the marginal density of y. And you can see that the denominator here has nothing to do with the integral. The integral is with respect to x. Right? And because of that, we can get it outside the integral. And this will be the integral of the joint PDF from minus infinity to x with respect to x only. This is the way we find the marginal CDF. طبعا you do this if you don't have the conditional PDF. However, if you have the conditional PDF, you just integrate directly like here. Any question يا شباب؟ شباب stop me at 8:35 and start opening your cameras at that time or before even. Our quiz will start at 8:38. Okay. Yeah, before I continue, I already, when you start the quiz, you will see a statement, which is what KFUBM sent us, the integrity statement or declaration. You need to mark as preview before you start the quiz. I am just examining with this, so let me know if you have any problem. You should see it before starting the quiz. You need to mark preview or mark reviewed, then you will start the quiz. Let me know your feedback about it. This is required by KFUBM. And the second thing, there is this new feature that KFUBM enabled and asked us to enable in all the exams, which is the lockdown browser. You have received an email, I assume, about it, right?
Yes.
Yeah. Well, basically,
Yes.
this is when we have an exam on Blackboard, your browser, you will not use the normal browser اللي هو Internet Explorer ولا Firefox or whatever, or Google. You will use a lockdown browser given by KFUBM, by the Blackboard itself. So you need to start get used to it. And because of that, I created a dummy quiz. I called it test quiz, test. And I explained why is this test for lockdown browser. It will be enabled today at 4 p.m. and it have infinite number of trials. So try to access it and try to, you need to download the browser and so on, the lockdown browser. Try to access it with this. Let me know if it works and you have any problem, or if you have any problem. If it works, let me know that it works. Because this is that we will have to use in the future quizzes and exams inshallah. Until the exams are physical. So far we don't have physical exams. طيب يا شباب هي هيطلع لكم الساعة 4 اليوم. So just whenever you receive it, you have infinite number of trials. It's a test quiz. Questions ما لها علاقة بالmaterial. Just 4 questions about anything. واضح شباب؟
واضح دكتور.
واضح
This
دكتور.
is needed. Our midterm will be in 2 weeks. So we need to make sure that you are comfortable with this, no problems and so on, because the midterm will be based on this lockdown browser. طيب. Now the interval conditioning is a conditioning on an event B such that it says that B is an event that Y is between 2 values. هناك في البوينت conditioning قلنا Y equals a specific value, right? This is called point conditioning. Here, no. This is interval conditioning. We are conditioning that Y lies between YA and YB. So in this case, the conditional CDF of X given Y is between YA and YB equals, by definition, the joint probability of X less than or equal to X. لأنه هذا إيش? This is coming from the the CDF. CDF of X by definition is the probability that X is less than or equal X intersected with the condition. Right? Divide by the probability of the condition. So this comes from أول event اللي هو X less than or equal small x comes from the definition of the CDF. Intersect with Y between YA and YB. Divide by the probability of YA, YB. Now in order to find this, the numerator, this is the double integral for Y from YA to YB, and for X from minus infinity to infinity, to X. And in the denominator, this PDF, the probability that y between ya and yb equals the integral from ya to yb of the marginal, right? PDF of y, which is given, which هذه عبارة عن المارجنال, which is basically the integral of the joint PDF about x from minus infinity to infinity. تمام يا شباب؟ أي سؤال؟ Now, if we open up and write this in terms of the CDF, this integral لو تتذكروا هذه this is integral from ya to yb minus infinity to x. This has 4 values لو تتذكروا, which is fx y at x and yb اللي هو limits الأولى minus the joint CDF evaluated at x and ya minus الفاليو at yb and minus infinity هتعطيك 0 plus fxy at x at ya and minus infinity, which will give you 0. عشان كده we have only 2 parameters here or 2 numbers here, 2 functions here in the numerator. واضح يا شباب؟
Yes.
divided by هذا الانتجرال اللي هو integration أو probability that y equal y between ya and yb equal fy evaluated at yb minus fy evaluated at ya. تمام. Now the conditional PDF of x given this same condition, interval conditioning, y between ya and yb equals the derivative of what we have found already before. The derivative of the conditional CDF. Now if we differentiate the conditional CDF, we only differentiate what is function of x. You can see that the denominator is function of y, so nothing. The denominator is function of y. The numerator is a function of x in terms of the integral. هذا الانتجرال. So if we differentiate an integral with respect to x, the integral ايش يصير له؟ Goes away, right? Disappears. And we end up with only one integral about y. تمام؟ طبعا this is given that the denominator is not 0. So again, the condition هذه معناها بالphysical meaning, the condition is not impossible. تمام؟ Don't ever condition on an impossible event. It's not impossible. هذه معناها كده. The denominator will not be 0 if the condition is not impossible. Okay? So next time, inshallah, we'll come to the example. We have this example. It will take some time. I will not be able to finish it before the quiz. طيب, please enable your cameras. We have